Okay, thanks, Greg. So as Greg said, there are a series of other things going on that we're involved with at Nottingham, and I just want to take you through that. And really the sort of starting point for me is that Greg's gone through a lot of the science that's involved in this bioenergy program. And my starting point for this is, well, okay, let's assume we can do all of this really complicated, hard science stuff that I frankly don't really understand that well. So I'm hoping that by the end of the program I'll understand it all a lot better. But just because we can do all of this from a scientific point of view, does it actually make any sense? So from an environmental point of view or from a financial point of view, does it actually make sense to do it? And that's where we start at with this concept of sustainability. So within the program that we're looking at this sustainability framework, as Catherine Smart calls it, when she gives this type of presentation, in that there are three aspects that we need to think about from any technology that we develop. So one is from a social point of view, is it acceptable? So will society think it's a good idea, broadly speaking? Is it environmentally sensible? And then is it economically sensible? And we bring all of these three things together to try and have an overview of whether this sort of new technology and this new scientific approach is actually going to make any sense in a wider context. And that's really what I want to go through with you in terms of the sort of wider sustainability aspects of bioenergy that this program's looking at. So there are three broad areas that the sustainability part of the program is going to examine. I'm going to give you a little bit of information about each one of these. The first one is what's called life cycle analysis of the whole process, and that's really looking across the whole industrial process from when this really hard, horrible stuff leaves the farm gate and it gets turned into petrol, effectively. It's looking at the environmental and the energy accounting that needs to go into that. So how much energy do we need to put into transforming this straw into petrol? And what are the sort of carbon footprinting impacts of that? The farm systems assessment is the part of the project that I'm particularly involved in, and that's looking very much at the farm level issues. So in terms of different crops that farmers can grow, the different energy that a farm can produce and the different financial consequences that can bring, and also looking at the wider sort of carbon footprinting at a farm level point of view, and I'll touch on some more of that. And then finally, there's more of the social aspects to this type of technology. So when we're developing a new technology, does it make sense? Will society like it? And if you want to think, well, is that really important? Certainly where we are here, all you have to do is think back to GM tomatoes. They came onto the market and they disappeared quite quickly because socially they weren't acceptable. So it's that side of the technology and the science that we need to get a handle on as well. So in terms of life cycle analysis, this is actually being led by some colleagues at the University of Bath. And what they do is look at the energy that's needed to convert straw to petrol. And what that involves is it involves them mapping out the whole process. So they set off and they look at all of the linkages that are involved in the industrial process. And they're calling this seed to wheel. So effectively from when it leaves the farm, goes through some processing situations that are going to change as Greg and colleagues improve the efficiency of this, and then you get to the end use in terms of petrol. So they map it all out and they calculate how much energy is going into the process. So it's really an energy accounting exercise. They're just mapping out how much energy goes in, and hopefully the process will generate more energy out than it actually takes to actually produce the petrol. If it doesn't, then we've got a problem. But if it doesn't, then we need to know that before we sort of go to government and say, oh, this is such a great thing, why don't we do it? If we're actually going to use more energy to produce this petrol than it's actually worth. And then the environmental aspect is looking at carbon footprinting, in effect, or things like that. So what are your carbon emissions from doing this process? But they're also going to be looking at some wider points within that. So within the environmental side of things, they'll be looking at particular hotspots of the processing, because there may be particular parts of the processing process, not a very good phrase, but there'll be particular aspects in that where they may look at and go, well, that uses, for example, a lot of water there, and that then creates other environmental problems. So it may be that when we're looking at this industrial process, there are bits where they go, we're not really happy with that, and are there ways that we can actually try and improve that bit of the process so, for example, it uses less water. But the bottom line of this, as I've got there, is does it make environmental sense? If it does, that's great. If it doesn't, then we need to keep working on the process to see if we can come up with an efficient way of doing it so that it does make environmental sense. Okay, so that's one theme. The second part is the one that I'm particularly involved in, and this is looking at issues at the farm level. And whilst farming has sometimes got a very simplistic view, it's really quite a complex system, and that's why we're looking at it at a system level in terms of the farm. We're not just looking at a crop of wheat, we're looking at what farmers do on farms, mainly arable farms, because they can grow a range of crops, they use energy, they produce things. And we're particularly looking at these three things, energy, environment and economics. And what we will be doing is we're going to be measuring what's called the trade-offs. So if we want farmers to produce as much energy from a farm as possible, we might have to pay them to do that, because that might not be the most profitable plan for them, for example. So depending on what we want farmers to do as a society, we need to know what the trade-offs are. And to do that, we're building a farm systems model, which is abbreviated to METER. So if you hear about the Nottingham METER model, that stands for Managing, I'm going to get this wrong, Environment, no? Narissa, tell me what this means.
Managing energy and emissions trade-offs in agriculture.
Thank you. Managing energy and emissions trade-offs in agriculture. We had at least an hour meeting to get that name. So we're looking at just at the farm level, how much energy comes in, how much energy comes out, looking at the impact of various options, again, so carbon footprinting at the farm level and the different economics that you get from different plans at a farm level of what the farmer can do. And we're looking at it at a system level because, as I say, farms are not just a single crop. Particularly arable farms, they grow crops in rotations, they grow crops at different times of the year, and all of these possibilities mean that there are different energy inputs and outputs needed that we need to try and capture. Now, the other thing about farmers is that they tend to like doing their own thing. Most of us do, but farmers in particular really like doing their own thing. And so we're going to go and talk to farmers via some in-depth surveys. We're going to talk to about 250, hopefully, and we're going to ask them about their perceptions and their thoughts about using straw for biofuels, and also we'll ask them about other crops as well. And I'll come on at the end, I'll talk about what some of the other programs are doing in terms of bioenergy. But we're going to ask them about their perceptions and their understanding, because currently a lot of farmers in the east of England take this stuff, it comes off the back of a combine and it gets chopped up into bits about that long, and then it gets incorporated into the soil. And this funny stuff actually returns some nutrients to the soil, but it also helps the soil, it gives it soil structure. So if we're taking this away from soils, then there are some issues that farmers will possibly not be happy about. But the other thing is that by chopping this up and incorporating it into the soil, it means they can get on with their work a lot quicker. So if we're going to them and saying, actually what we want to do is we want you to bale this so we can use it for fuel, some of them may not be very interested in getting involved in that, and we need to capture what their concerns are so that we can overcome that if we're going to actually have an industry built around this type of technology.